Hello everyone. I hope you guys are doing absolutely fine and good. Before heading over to this video, I would like to summarize the things that I've already done. First, I've explained the concept of Fibonacci series. Then, what is a Fibonacci series? What is a Fibonacci series and how it's formed, an algorithm for it, and a Java code in order to elucidate the programming in Java. Then I've also explained the performance matrix such as asymptotic analysis, time complexity, and space complexity. And I've also introduced concepts such as amortized analysis, average case, best case, worst case in my previous videos. And then finally, I've evaluated my performance of the Java code that I've written. So if you haven't seen these videos, I would highly recommend you to first go and watch these set of videos and then come to this video, because now I'm going to explain recursion in Fibonacci series, or printing Fibonacci series using recursion. So many of you might find recursion a little bit difficult because the way things are being how a function calls itself and how things actually function. So I'll try my level best in order to simplify things in this video. So without any further ado, I'm going to continue to the video. So before anything else in the program, all I'm gonna say is first going ahead to the mathematical equation of Fibonacci series. So what is the mathematical equation of the Fibonacci series? So the mathematical equation of the Fibonacci series is we have f of n. So what is f of n? F of n is nothing but a function of n, where n can be any number from 2 to positive infinity. So f of n is nothing but f of n minus 1 plus f of n minus 2, where n is from 2, 3, 4 till positive infinity. Then a question might have arisen in your mind. Where is 0 and 1? So that is what we actually define in a particular set of functions. These are the prerequisites for the set of equation, or we are going to predefine the values of 0 and 1. We have f of 0 is equal to 1, and then we have f of 1, it's going to be where f of 0 is 0 and f of 1 is 1, which is very similar to A and B in our Java code. So if you haven't watched those videos yet, I will post all those videos in the description below. I would recommend you to go and first watch those videos. You will have better clarity in order to understand this paradigm. So coming over to the function, the mathematical equation, we have f of n is equal to f of n minus 1 plus f of n minus 2. So let's go ahead and solve for, say, f of 3. What will be f of 3? So according to this equation, f of 3 will be nothing but f of 2 plus f of 1. Wait, what? Where is f of 2? Where is it? How will we even calculate f of 2? We know what is f of 1. Here it is. F of 1 is 1. What is f of 2? So hence, in order to calculate the higher term, we need to know the value of function of its lower term. So coming over to what will be f of 2? F of 2 will be nothing but f of 1 plus f of 0. So hence, that will nothing be f of 1 is 1 and f of 0 is 0, which will be equating to 1. So we already know, according to our Fibonacci series, our second term of the Fibonacci series, that is the n minus 1th term. So if we have f of 2, we will have f of, not the n minus 1, I'm sorry, the nth term, f of 2 is 1. So hence, Now we are able to calculate the value of f of 3. What will be the value of f of 3? It will be nothing but 1 plus f of 1, which is 1. That is nothing but 2. So that is similar to the algorithm I've already explained. Of course, Fibonacci series is never going to change. So that is the mathematical equation which we'll be using in our recursion code in order to call it recursively. So you might have got some idea of what we are going to call. We are going to call the values of the previous functions in order to calculate them till we reach 0 and 1. Once we reach 0 and 1, our base condition is met, and then we are going to calculate the further parts of our series, or the further numbers of our series. So heading over to the explanation. So what will be this case now? So let us take the example of f of 5. So of course f of 5 will have its n minus 1th value of f of 4 and n minus 5th value, that is nothing but 3. But wait, it will never go to 3. If we stack, the first function that is going to be called is f of 5. Why am I writing it down? It is because in stack, the function that is going to be called first is the one that is present at the top. So it follows the formula of LIFO, that is last in first out. The function that is put in the last will be called first. So of course, the second function that will be stored in the stack will be f of 4. Why not f of 3? It is just because in the function of f of n equals f of n minus 1 plus you have f of n minus 2. This is the first function that the program is going to look at while recursively calling it. So f of n minus 1 here, in this case for f of 5, is f of 4. So this function will be called. Similarly, we are going to have, let us say we are going to have f of 3 now, that is n minus 1. Of course, the formula is never changing. And for f of 4, we have f of 2. So what is the next function that is going to be called? F of 2 will remain that as it is. So you can look at the pattern. It will only call the left part of the recursion depth or the recursion figure that I'm drawing. So the next function that will be called will be f of 3. So in any of these cases, do we know f of 5? No, we don't. Do we know f of 4? No, we don't. Do we know f of 3? No, we don't. So hence, it will again call back the function. Since the base condition is not met yet, we'll have f of n minus 1, that is f of 2, and then we'll have f of 1. So the next function that is going to be called is nothing but the left-hand part of the recursion figure. That is going to be f of 2. So if it's f of 2 now, do we know the value of f of 2? No, we don't. So hence, the next function that is the next value is f of 1 and nothing but f of 0. Hey, what? We know the values of f of 1 and f of 0. F of 1 is nothing but 1 and f of 0 is nothing but 0. So we get the value of f of 2. So hence this is met. So now this thing will be removed from the stack. So I'll just try and remove that from the stack. I'll just select it and just come to out. So I've removed it from the stack. So coming back again to our problem, we have calculated f of 2. So what will be f of 2? F of 2 will be nothing but 1. That is 0 plus, according to the function, it's 0 plus 1, that is 1. So hence the value of f of 2 is going to be 1. So the next function that is going to be called is f of 3. But do we know for f of 3, what is the function that needs to be called? We know f of 2, so it will be here. And then do we know f of 1? So it will go into the right-hand part, put f of 1 here. And since we know f of 1, it will no further call any function and add f of 2 and f of 1. So what will be our value of f of 3? F of 3 will be equal to 1 plus 1, which is going to be 2. So this whole thing is now cleared. Since we know f of 1 and f of 3, it has already been called. We'll remove both of these stuff from the stack. So now what's left is f of 5 and f of 4. The next function, as it's equal, it is visible. I will take the value of, say, the value of f of 3 is 2. But now the next function that it has come across is f of 4. But for f of 4, we need the value of f of 2. But still, it will go down to f of 2. And since we have not met the base case yet, it will call for f of 1. We know what f of 1 is, and we know what f of 0 is, and hence it will again come back and give the value equals 2. So it is going to calculate. We cannot neglect the fact because the program has not stored the values of f of 2. So hence, it does know what f of 2 is. So it doesn't know what f of 2 is. So hence, what it's going to do is, now for f of 2, it is going to calculate the value that is going to be 1, because f of 1 is 1 and f of 0 is 0. So hence, for f of 4, it will come back here, and then what it will come across? It will come across f of 3, and it will come across f of 2. So hence, it will calculate f of 4, that is going to be 3, since we know what the value of f of 3 and f of 2 is. So it will just be 3. And finally, it will eradicate this from the stack. It will delete this part from the stack. And now what remains is f of 5, and what remains is f of 5. So we already have So hence, for f of 5, we have the values of f of 4 and f of 3, and so it does not know what f of 3 is. So now in the stack, we again have f of 3, and then for f of 3, we have f of 2 and f of 1. We don't know what the value of f of 2 is, so again f of 2 is going to get added, and then we'll have f of 1 and f of 0. So we know those values, which is equal to 1 and 0. So f of 2 is going to be 1, and f of 1 is already 1. And so f of 3 is going to be 2, and that is how we'll be able to find f of 5. So what will be f of 5? F of 5 will be nothing but 3 plus 2, which is going to be 5. So similarly, as each function gets called, everything of the stack gets cleared eventually, and then we have the final terms. What are those final terms? We have the final terms as, the first one is f of 0, which we already have defined, f of 1, which we have already defined, and then we have f of 2, which first gets calculated on this part, that is 0, 1, 1, and then we have f of 3, and then what is going to be f of 3? F of 3 will be nothing but 1 plus 1, that's 2. We have f of 4 as 3, and then finally f of 5 as 5. So that is our Fibonacci series for n terms, that is 5. Thank you for watching. Now, and in the next video, I'll be writing a Java code in order to execute and print the n set of Fibonacci series with the help of recursion. Please like, share, and subscribe for more interesting content. Thank you and have a nice day.